Invited to speak about crypto economics here. I did present that at UC Irvine, so if you take a look at my LinkedIn profile, you'll actually see my presentation at UC Irvine on crypto economics. I want to read a few more economics books before I create a new presentation on crypto economics. There's just so much in the space that I want to make sure I learn more before I do that. So today I'm going to talk about the world of decentralization. Blockchain was the first decentralized technology. Technically not true, but it's what the world knows as the first decentralized technology. I'll mention which was actually our first decentralized technology in the presentation. There are three different types of decentralized technologies. The first decentralized technology we all know is blockchain. The next that I'm going to speak about is IPFS, which stands for Interplanetary File System, which you had mentioned about of having decentralized storage. So I'm going to actually go into that. And then third, I'm going to speak about mesh networks, which was actually a true decentralized technology that originated from the military. That was here way before we had any of this decentralized technology. So I'll speak about all of that. So first, I'm going to bring it back. Okay, we're going to assume blockchain is the first decentralized technology. Where did the first decentralized technology originate from? It was Bitcoin. Okay, Bitcoin has its own white paper, and I brought that over here for us. So we'd like to probably pass that around if we have that. I would encourage you to read it. It has what is our first white paper ever, and it's not a difficult read. Bitcoin was invented as cash for the economic world. And you'll see that right in the title of the white paper. And I again encourage you to read it. The first few pages not difficult to read. It gets into math, and I get lost a bit, but consult any mathematician, and I'm sure they will be able to vet whatever is written there. So I do encourage you to read that. So a lot of people ask us, well, what backs Bitcoin? This is the true question for everybody. We want to have a central authority and all of that. What backs Bitcoin is proof of work. This is the consensus algorithm behind Bitcoin. There's many out there now. There's proof of stake, which I totally do not like, and there's a few other out there that are trying to expand on it. We have the original proof of work, which works. It can be a metaphor in many different ways, actually. And so I'm going to describe that here for you. It's a lot of terminology. This was supposed to be an animation, so I didn't throw all of these words at you at the same time. If you don't understand it, please try to go and research it. This is what backs Bitcoin. This is what makes Bitcoin secure, and this is what has allowed everybody else to start looking to other blockchain technologies as well. So everyday people like you and I, this is what Bitcoin was made for. It's cash for you and I. It's peer-to-peer cash. I should not have to go through a central authority. Now, mind you, this is not about, a lot of people have a misconception about this being against the banks. This is not against any banks. This is against central banks. But we need our retail banks, right? People need money. People need to borrow money. People are always going to want to spend more than they actually have. And so this is why we're always going to need retail banks. So, and they can build their products based upon Bitcoin. Imagine a system where instead of having this amount of gold that we'll never know how much they have, if they actually use Bitcoin as their actual backing currency, we could actually verify how much money a bank has, and we could figure out if they're actually overspending them or creating more fiat based upon them they actually are supposed to be. And this is the way a basic Bitcoin transaction runs, okay? There's going to be someone like you and I. So there's basically you, which is us over here. And again, a lot of terminology. Please just try to research it and check it out. So we're going to send our transaction to something called a node, which is usually going to be our bank, which could be Coinbase. If you're familiar with Coinbase, that's our node. They will be a full node. There's a fallacy out there that all of us needs to be nodes. This fallacy is that Bitcoin is supposed to be this everybody decentralized. And there's this idea of decentralized everything is a complete fallacy as well. You can't have true decentralization. So you got to have decentralization in a centralized system, and you need to have centralization in a decentralized system. And that's up to you to figure out. How much decentralization do you want? How much centralization you want? It's not perfect. It's not either end of the spectrum. You have to find the middle ground that's going to be best for your product. And so what we're going to have here is we're going to send our transaction out to a node, and then this node is going to send this transaction out to something called these cryptographic miners. And this is basically what a mining machine is. And I'm sure as a lot of you investors, probably have looked into mining machines. This isn't a mining machine. I was in mining in 2013 back in the time. I was able to actually mine Bitcoin at that time. And so those were great times. And what they do is they do a bunch of calculations to find a block, which then settles your transaction. Think of it as a lottery system. Imagine these machines just constantly doing the lottery system, and once they won the lottery system, they let the world know, hey, I found this lottery system, and this is what the proof of work is, constantly going through this lottery system. This is not something that you can just solve right away. It's a lottery system. Finally, they solved it. They spent all this work to find it. Now they send this transaction out to everybody else, and everybody else can validate this transaction right away. They don't need to go through the same work. They can just all of a sudden say, okay, here are the transactions. They add something called a nonce, and then they hash it. These are all these technical terms. And then they have something called the hash cache. We solve the hash cache problem. And once they solve this problem here, they can pass it out, and then everybody else can validate this, and everyone says, oh yeah, that's true, okay, that's good. And now a block has been found, and a block includes a bunch of transactions. And then they start working on the next block, and now you have your blockchain, right? So this is how the term blockchain got into existence. So yeah, you got to find a block, you add it to the chain, you send it to the other miners, and then they send it out to all these other miners over here. And this is a really different system. She brought up TCP. This is very, very important because Bitcoin can be a completely new system. I think we've seen Bitcoin in just a very general way. So the first misconception that we have is people say that Bitcoin cannot scale. Bitcoin can scale. Okay, so I think a lot of people just do not have enough belief in entrepreneurs. We can definitely scale. We've already proven that we can scale. We just have to raise the cap size for everybody who understands how Bitcoin works. We just need to remove that block cap and we can scale. There is no question, no doubt about that at all. You have to think of Bitcoin as cash. That is what the white paper says. It's right in the title of the white paper. Bitcoin is meant to be cash. It's me giving you money, cannot be reversed. I am a merchant. I have a brick and mortar store. Well, I want Bitcoin. Why do I want Bitcoin? Well, first, the sender pays the fee. I don't have to worry about any credit card fees. If I'm doing $1 million in transactions, that's $30,000 in savings to your bottom line right away. So sender pays the fee. Next, the transaction can't get reversed. I don't have to worry about somebody calling up the bank and calling fraud, and now all of a sudden I lose the sale and I lose my goods. And the third is instant settlement. Right? So we have something in Bitcoin called zero confirmation, which allows for instant confirmation, which means that this transactions get settled right away. I don't have to wait so much time for the transaction to get settled. This is powerful. And when we start understanding the proof of work system, we start understanding it's a truly capitalist system. All of these miners are competing against each other to create the best hardware that will be able to solve this hash cache problem. And by them working this hard to find that, they're going to create better, efficient hardware. They're going to create better storage systems because the fallacy out there is the blockchain is going to get bloated and there's too much storage to be out there. Well, guess what? They're incentivized to go and find better hard drives. They're going to make better hard drives in Seagate. They're going to make better hard drives in Western Digital and all of these other companies because they want to scale. They want more transactions. They want you sending transactions because they will make more money that way, and they will be better entrepreneurs than any of the other companies that are out here right now, and they'll even find better bandwidth solutions. So finally, I'm going to bring it to TCP/IP. Right now, our current system right now, you have to go many hops before me to send data to you. You have to go from my phone to my router, to another router, to the tower, to the ISP, and then back all the way again. And this is a lot of hops. When you see this chart over here, you can get to the next person in 1.32 hops. Now imagine going from 10 hops to 1.32 hops. This is efficient. Instead of having to go through all of these systems, you just have this, not a central system, it's not a centralized system, it's more of centrality, where you have all of them, it seems like centralization, but they're all connected. And now you're able to send data from a person to the other person without having to go through all of these hops. And we can start seeing Bitcoin as the new TCP/IP. Now that is a statement, but I encourage you to actually see it that way. And we can start building on top of Bitcoin, right? Not around Bitcoin. What did we do with TCP/IP? We built HTTP, right? We built many other systems. We encourage to build on top of Bitcoin. A lot of these solutions that we're building can be built on top of Bitcoin, and we can create this new TCP/IP mechanism. And soon we'll have smart contracts. If you're familiar with that, we have smart contracts on permission ledgers, on public ledgers, whether they're Hyperledger, Quorum. I've taught courses on Hyperledger, I've taught courses on Quorum, I've taught courses on Bitcoin, Ethereum, all of these, 200 hours over of just lecturing over these. And after a while, you start to see a lot of the ideas that people are thinking about, and there are a lot of great ideas. So eventually we're going to start have smart contracts on Bitcoin also as well, and Ethereum is great also as well. I can do that. It's just we'll not be able to scale as fast, and if proof of work, proof of stake comes into existence, this is not good. And yes, we can have fees as fractions of a penny. We can have fees fraction as a penny. It has been proven so. So yeah, it'll be exciting stuff. Now, here's the thing. A lot of you will be looking into Hyperledger. A lot of people looking into Quorum. This is great. All I'm encouraging here is understand both sides of the spectrum here. Permission systems are going to be great when you're sending tons of transactions all the time, right? If you're getting into millions of transactions per second, you're probably going to want to use a permission ledger because the fractions of a penny can actually add up to be a lot of money. Now, if you're building your idea around not having as many transactions per second, you might be better off using Bitcoin. And the reason I say that is because now you don't have to build your own infrastructure. You don't have to hire hardware engineers. You don't have to hire networking engineers. You don't have to hire business architects. You'll still need to have business architects, but you won't have to invest in so much of the infrastructure because that's what the Bitcoin system is there for, right? So, and Ethereum, but again, I will encourage you to take a look at the new developments and the forks of Bitcoin that are happening out there, are having a lot of new things that are being created out there, and you can actually start building on top of a lot of this stuff, and so you don't need to now utilize your own infrastructure. You can just utilize the infrastructure that's already there, and it's a secure system. All right, so let's go into IPFS. So blockchain was the first decentralized technology. Now we have IPFS. This stands for Interplanetary File System. Why interplanetary? I do not know, but it's much nerds making this stuff, so might as well make a cool name out of it. The idea is that we all have hard drive space, right? We have too much extra space. Why are we storing it on Amazon? Why don't I just store some of yours? So why don't I store some of yours? And then I'll pay you to do so. And guess what? If you're my neighbor, I'm going to get that data faster than I would ever get it from Amazon. And guess what? If you wanted to attack my data, if it was on Amazon, what do? You attack Amazon. But if I have my data multiplied many times and on a bunch of different systems, who are you going to attack, right? First, you won't know who is storing my data. And then, even if you attack that person, there's other people that have copies of that data, and it's still cheaper than Amazon. Now, this is going to integrate with a lot of your blockchain technologies because unless you're using the permission ledger, you can store more data on the blockchain. However, you probably will have a better system of utilizing the blockchain as a database and storing your actual data using IPFS. This is going to, and I'm going to show a full network of combining all of these, and it'll start to make sense. And so, once you download your data, now you're also required to upload that data. And so now, not only are you're also contributing to the system. So this is what allows to have a more of an exponential use case of it. Instead of downloading from this central location, all of us can now share. And so we're able to download and stream faster. And so this allows access to files much, much quicker than we would ever have with Amazon. And so, again, it can be effective against DDoS attacks, right? Amazon was taken out before, and so half the internet went out, that's not good. So this is effective against DDoS attacks, against any type of censorship, There's people in third world countries that want to get their data out there. I still remember when Twitter got popular is, I remember when the Shah of Iran was, not the Shah, but whoever the president was completely controlling the entire, country over there, but he controlled the internet. He couldn't control SMS. And if you remember Twitter used to be SMS. And so the people were able to get their voice out by using SMS. So they would use SMS to get to Twitter, and then Twitter was able to publish it there. And then I was like, oh my God, this is cool, right? Anyway, so this is what we can do with data also as well. There's many controversial figures in the world, and as much as we don't like their ideas, they should still be able to share some of their ideas. It's just a belief, and so this can kind of help do that. And so obviously we don't need to rely on AWS like Amazon and at all. So this is a way for us to be able to just rely on ourselves, right? And yeah, so we'll combine it with blockchain. I'll show that. So these are. I always even regret trying to put this on here. These are other companies or ICOs that kind of are implementing this. They are creating their own version of it. They are not implementing IPFS except for Filecoin. Filecoin was created from Naval Ravikant, which he created Angel.co, and he created the paperwork for accredited investors to invest into ICOs through SEC regulation. and he was the first person, and he created Filecoin through that. And so Filecoin is an implementation of IPFS that has an economic incentive. So that way, if you store on my hard drive, you pay for it. Filecoin does that. And that was the first ever ICO that was through SEC regulation that was in. And these are a few other coins. Mesh networks is the third technology. This is decentralized communication. We're always having this debate about net neutrality right now. You know, should we have it or should not? And the answer for me is like, why are we even having this debate? You know, why don't we just decentralize our communication? And we all have cell phone signals. Why don't we just bounce off of each other and get to run? Now, obviously, it's not efficient. This is going to be new developed technology that needs to be developed. There's no question about it. But why the hell? Why do we even need to have, you know, these ISPs, which are going to be controlling our bandwidth? You know, and so that's just the basics of it. So originally created by the military, right? So if you're going to when you're in war with somebody, you take out their communications. That's a big thing. And so they created this a long time ago. This is probably the real first true decentralized technology. You know? All right, so that was it for Mesh. This has a lot to be developed. There's a lot of people that are working on economic incentives with this also as well. Basically, you know, you jump into another country and you can get connected to the internet right away, and then you pay them to do that. So this is the economic way to do that. So this is combining all of those technologies. Now again, it's not about decentralizing everything. Find your, you know, you're going to want to have centralization and decentralization. You want decentralization and centralization. You just can't decentralize everything. So the simple idea is this, right? So you have data, right? So what you're going to do is from your phone, you're going to send it to a mesh network over here, which are a bunch of other communications. They don't have to be phones. They can be computers. They can be towers, your own towers. But it's decentralized, right? And then you can send that data to the IPFS network. So this is going to be somebody's desktop, somebody's hard drive over there that has space over there, and many of them actually, not just a single point, otherwise that's going to be taken out, could be taken out. And when you store the data on IPFS, it gives you something called a hash, and this hash is your reference to where that file is. When you have that hash, you can retrieve the file. And so then, if you want to have true data integrity, somebody could change that file, or somebody could change that file, store it in a different location, have a different hash, and say this is the real data. But if you want to have true data integrity, when you store your data on the IPFS network and you get your hash, you then store that hash on the blockchain. And when you store that hash on the blockchain, you've now created that timestamp that data was that data at that time. And now you can have real, true data integrity. So that is combining all of that together, and that's all I have.
Okay.
Thank you so much, Ron. That was a really nice deep dive, and I think I'm going to have to sign up for your classes. But you gave us a good intro to some pretty difficult concepts. So one thing that I struggle with is this idea of you know, public versus permission ledgers. And is it fair to think about it? Like I'm always trying to translate things into sort of the old way I used to think about software. Is it fair to think about it similar to like B to B versus B to C, or is that completely wrong? Is like a public ledger sort of a consumer B to C, and the permission is more like B to B, business to business? Is that a way to grapple with it?
It's mostly that way. When you want to have a public blockchain, it's generally when the world needs to reach a consensus. This needs to be money, this needs to be property. You know, things like land rights and all of that. So generally public blockchains can be utilized for that. When you want to have data integrity that needs to be utilized for the entire world, is basically when you're going to do that. And so most applications are going to be focused on Hyperledger and Core right now. But the only I was trying to point out is that there's a gaming system out there. There's a company out there that's making a gaming system where you get to bet against other gamers that you're going to win. Now, they're creating a token to do that. And to me, this is unnecessary. I think their business model has to do with creating this betting system. Now you can say you can do that in the dollar. However, there's going to be more transaction fees also as well. And crypto is very inexpensive. So there's already an economic incentive of just creating that idea. Them creating that token is what's questionable to me, because once that person wins the token, what are they going to do with that token? Most likely they're going to cash out. So they're going to convert it back to dollar or hopefully Bitcoin. So why not have used Bitcoin in the first place? So that's where you have to start figuring this out. You know, where you know where a true token is going to be needed. And so, you know, but I think when you're going to have tons of transactions, you know, if banks are doing millions of transactions a second, they're going to need some type of permission blockchain, because using the public blockchain is going to be too expensive for that. So that is probably where, you know, it's difficult to say. I think maybe 90% of real blockchain use cases will be utilizing a permission blockchain, and some of them could use a public blockchain instead, maybe.
Okay. Thank you. Okay, I'd like to introduce our final speaker, Mohan Johar. You have your